Hey, hi guys, good morning. Soumya, did you join from two machines?
Yes. Speaker
Okay.
laptop problems. Speakers
Okay.
are not.
No issue.
Right.
Okay. Okay, let me get started. So yesterday we were discussing the basic introduction to Pig. So why we need to go for Pig and its Pig architecture and basic load, store and dump and describe. Okay. And how does that MapReduce job gets executed, and how to see those log messages. So till that level, and we have seen the basic arithmetic operators, logical operators, and some of the comparison operators and all. Okay. So now let's enter into the relational operators. So some of them, so a couple of them we have already seen there. So for each, so from here onwards, I will be comparing all these commands with your SQL commands once again. So your tuple is like a record and bag is like a table. And whenever we say a command for each data, so this is a bag or called as a relation or an alias. For each data, generate F1, F2. So this is like select F1, F2 from data table. Okay. And if you know the column names, you can use this. If you don't know the column names, you can use the positional notation to access the first column and second column like this. Okay. And it allows us to specify them, the aliases for them again. So renaming those columns, renaming in the sense not in the, anyway, we don't have persistent tables here. So we'll just be loading them, and while using in the subsequent commands, instead of using this as $0, if you want to have it as first, you can rename them. You can provide the alias. Okay. And in case if you want to select all the columns, all the fields, yes, use the generate star. It's like select star from data. Okay. So that one we have already seen. Let me start my view. Okay, let that get loaded. So we have already seen that. Okay. So when you have select, two columns are there, select F1 comma F2 from T1. Its equivalent one in this is for each T1 generate F1 comma F2. Okay. So next we have group. Okay. Use this one. So group is same as our group by in SQL. So to group your records by a particular column. Okay. So group by department or group by some other values. Okay. So let me explain this syntax. So I loaded this file. In this, I have only the student names and age and GPA. So three fields are there, ages and the GPAs. I have loaded them. So group A, this relation by age. So if I group this, I have two records with age 18. So that's why you will get that 18 comma. Inside that you will get an inner bag, which is of with same schema as A. Okay, so 18 comma and here two records, it matches that. And 19 comma, with 19 I have only one record, so that is in a bag. In 20 I have. Okay, now let's see some of these commands executing in the session itself, and a few I will leave it for your practicing. Let's say if I have this data bag and if I group by F1, so I should get, for 1 I should get 3 records, for 2 1 record, 3 1 record, and for 4 2 records. So my main intention to show this is not to see the results. You should observe the schema for that. Okay, so I have this D yesterday which I loaded, F1, F2 and F3. So since I didn't close my grunt shell, the pig session, so it is still available. Otherwise, if I could have closed it, then I might not be able to access this D alias. Okay, so then obviously I need to reload this data into that D. Okay. Now, since I have it in handy, so let me create a alias group equal to, so group D by F1 and dump grouped. And for your practicing on this, on all these relational operators and all these commands, I'm pasting one Motors Pig chart sheet. So this is from one of the good PDF that I have. So this big cheat sheet, which contains all the commands. So this one I will go through quickly. I will give you one quick glance. And also into your examples with source code. So I pasted that pig folder already into your Google Drive. Okay. So the pig folder is copied. This contains all the examples for your pig scripts, like so group by. You can see this. So you have these examples there itself. Okay. So this coding samples, I've placed it there, and everybody is having access to this Google Drive. Okay. So is there any way we can see the MapReduce script generated by BigQueries? You can't see the MapReduce job, but you can see at max the jar which it is submitting. That's it. So it abstracts all those information from us, like, so we can at max see, so what is the jar it is submitting. See, it's creating a jar file with this. And obviously if it is a .class or .jar file, then you will not be able to see the source code for that. Okay. It abstracts that source code from you. Okay. So it read this file and it returned these records. With one, I have 3 tuples. So here my main intention to show this is, here in the output, I got the same column which I used by group by, and the second field, I will always get 2 fields. So one is a primitive one. The first one is the primitive column, and second one is a inner bag whose schema is same as your input alias. Like if I describe this, describe grouped, you can see. So I have the first field named as group, which is of int type. Okay. So this is int type, the first field named as group. And second field is same as your alias that we used. We used group by group D by F1. And this F1 becomes the first field that is named here as group and whose data type is same as your F1. And second field becomes your alias D, F1 int and F2 int and F3 int. This is an inner bag. Okay, so this will be useful in generating the counts as well. So that's why I'm showing you this here, that schema. And flatten. Flatten is used to ungroup them. Anything that is grouped, if you want to ungroup them, you can use like, so flattened equal to, so for each group, generally for each alias name, specify the flatten of X, whatever that you want to flatten. Um, Syntax error, unexpected symbol at or near flatten. Or inside this, for each group, if I need to access this, one second. So if I already have this grouped value, or if I take this as nested schema 1, let me see what is there in the describe the spider. For each E, generate big script failed to parse. A column needs to be projected from relation for it to be used as a scalar. Okay. Let me see this syntax. Here it's like, so f equal to load slash user slash cloudera slash data slash nested hyphen schema dot txt using big storage of tab delimiter. Okay. And G equal to, for each F, generate flatten of $1. Okay, it should be used along with the generate, not just the, I think there is if I use, so this is the error message, like I have a wrong syntax in this slide. And if you use dump G, it should print as those values. Okay, so that unnests your flatten unnest tuples as well as bags. Let's say if you have this way, if you have an inner bag and this removes that, the outer curly braces from that. And if you have this, it will make all these things into one element, the tuples. Okay, so it's generally when we use any tokenize or something, when we get a set of values into one inner bag, and if you want to treat them, each of those values as a separate record, as like an outer bag, then we can convert, you can use this flatten. Okay, so this is something like array to string to array, or like array to rows. If you have an array of values in SQL, there is an array column. If you want to convert that into multiple rows, that is something like an explode command in SQL. Okay, and we have CoGroup also, which is same as our group, but here we can specify. Of course, even in group, you can specify multiple relations. Like if I have data 1 with owner and pet, and another dataset 2 with friend 1 and friend 2. If I want to group them by here in A by owner and B by friend 2. Okay. So for this, either you can use group or CoGroup, no difference. But the CoGroup generally we use in involving 2 or more relations, and group in one relation, where when you are dealing with one table. Okay, so the functionality is same. It groups them by the same keyword. Like if I have Alias, with Alias I have couple of records, from 3 records from here, and friend to wherever it matches this Alias in this, those 2 records also grouped into this back, comma this back. And if you see the describe syntax, so schema for this, it will be the group by field, the group and A, comma B. Okay, if it is not having any match, this is something bit similar to your inner join, but you will have this schema in this format. Your grouped column followed by your first schema followed by your second schema. Okay. Yes.
Siva?
Yes, Anil.
Is flatten like denormalization?
Flatten is like unnesting, ungrouping. Yep.
Denormalize, like you denormalize.
Is see, how I can say is like, if I have this, I will show you this one example, word count example, there you might be able to see. If you have an array of elements in a column, you have declared one column as an array in SQL. If you apply explode command on that, each of those fields will become separate records there, right? So maybe if I show you this flattened equal to, so that's why I thought of showing you the output of the grouped one itself, but that was throwing an error message because of syntax error. So flatten of $1. generate flatten expecting mismatched input. Sorry, this is again a keyword, right?
Keyword, yeah, that's exactly, yes.
Okay, so dump flattened. So $1 means my schema D, that whatever I used there. See, you got your original result back. Whereas if you print the dump G, dump group, you had these values into grouped, right?
Yeah.
So the second field is nothing but the group of these. And when I unnest them, it got ungrouped. You got the original result. It's like reverse of your grouping.
Okay.
Okay. So if you have any grouped result, and if you want to ungroup that back to your original, so you can treat that. Okay. So that's the one. And we have a count relational operator, count operator, to get the count of records in a bag. And this will be applicable only on like, same like your SQL, the count statement. So count of employee ID from employee table, select count. So that will give you the total count of records. Okay, with that employee ID non-null, right? Same here, like, so if you want to group, so if you want to get a count, first we should have a, if you have a relation, you can use that count. Okay, so here I have a databag.txt, the same one, f1, f2, f3. Here, if I want to know the each record count there, first I should have the values grouped there, the inner bag. So group data by f2, and then in each of these records, I can generate the count of them. Generate group, count of data. Let me explain you this with our example directly. Let's say I have describe describe D. I have 3 fields here, and suppose I grouped it by F1, and for each of these F1, how many, for F1 column, if I want to get the count of how many F1s are there grouped, then I should group by this column and then get the count. Instead of that, if I want to get the total count of records, okay, so then group 2 equal to, okay, so group 2 equal to, no, don't need them. So group B all. So this will generate one group, and you can count 1 equal to. So for each group 2, generate group, count of $1. Okay, whatever might be the second field. First field will always be group. Second field will be a relation. So, so for each group 2, okay, count of could not resolve count using imports, count of data. Okay, so here this count is a function, as I was telling you, like whichever takes a parenthesis. So this parenthesis, those need to be case sensitive. Those are case sensitive. So that's why when I used in lowercase, it was searching in all the Java language package imports. It didn't find that class with this name. When I used with uppercase, it found that. Okay. So dump of count 1. Let's see its output. Okay, so there are total of 7 records. And if I want to get the count of each one of them, like, so how many, so the count of first column, okay. So distinct count of first column values, if I want to know how many ones are there, how many twos, how many threes, and how many fours in the first column, then obviously I need to group by that column instead of group all. Here I generated group all, right? So now if I group D, group D by F1 and count 2 for each group 3, generate group comma count of $1. So this is not changing anytime. So for each your alias name, generate group comma count of $1. It's remaining same. Only thing is, if you want to have total count, then you should group by all, group alias name all, or if you want to get the counts by one particular column, so you can get this group by F1. Okay, so and dump count 2. It should print me 1, 3, 2, 1, 3, 1, and 4, 2. That way. Is that clear? Okay. So I hope it's clear. So next, order by to sort your values of a relation. Let's say if I have 1, 4, 8 this way, and load data is this is the data, and order A by A3, third column, and descending order 4, 3, 1. Okay, this is the syntax for that. Okay. And if you want to use any filtering conditions to filter out your rows, you can use this syntax. So load data to load your data. Once you load loaded the data. So filter A by F3 equal to 3. Only the records with third column matches with 3 value. Okay. So here we got those 3. And rank is something that it generates the ranks for these records based on the frequency and some other metrics. It's same like in your Oracle terminology. In the Oracle SQL, you have rank command, right? So can we see help or syntax for pick command in terminal? We have help command. Oh, for each and every command help? I'm not sure. So we can verify the previous counts. 1 arrived 3 times, 2 once, 3 only once, and 4 twice. That is what we have here. Okay. So for your help, so it displays all the commands. Okay. So generic pig Latin statements, diagnostic commands, some of the how to use them. So this sh, kill, run, exec, all these commands will be going one by one. Okay. Display this message. And help followed by command is not there, I think. So this way you don't have that. Okay. So just help is there. Help for to get the syntax of each and every command. We don't have that. Okay. So for that, anyway, I will give you one cheat sheet, commands cheat sheet, where you will get all the list of commands in one PDF, 2 to 3 pages of PDF. There you can refer the syntaxes for all of this. Okay. Next, distinct, same as your SQL distinct. Distinct A means it will remove the duplicate records. So 83412343343. If I apply distinct A, so I will get 433 only once. And to limit only to few records, same like in SQL, we have limit relation name, the number of records. Okay. And if you have 2 relations, so one is data 1 and data 2, and if I want to get the cross product of them, same as your mathematical cross product, you can use this cross command that is available. Operator. So could you repeat limit? Limit is same as your SQL limit. When from your results, if you want to view only the top 2 records or top 10 records, in SQL, how will we write? What do we write? What happened? Okay. So in SQL, we'll write, let's say instead of viewing all the records, if you have 1000 records in this, we apply here limit 10. If you want to see only those many records, then here, so limit T1 10. That's it. So when you use limit, why did it give 1 and 3 record? Why not 1 and 2? In this slide. Okay. So here 1, 2, 3. So okay, good catch. Let me run this and show you. So this is like even the results might change because you can't guarantee how many reducers it run, and out of them it picks in any order. If you run the same MapReduce job again and again, And if you compare your reducer files, you can't guarantee that every time in part 00 file, you will have the same records, because it distributes your records every time, and within one record file, you will have some sorted output within one part R file, but you can't guarantee that. So with every run of your MapReduce job, you will get the same records in the same order in your part 000 file. If you are having multiple reducers. If it is just one reducer, and again here limit, the same applies here with your pig and hive and impala. It's not like top 10 or top 20 always. Okay, if your records are sorted and if you have the sort by command, then limit means the top 10 will come. Otherwise, it randomly reads that entire. It reads that entire file, and while printing that, it picks up the two records randomly. Okay, so maybe if I want to limit this, okay, so dump limited. Let this get completed. It's running two jobs, one after the other. So here 1, 2, 3, 1, 2, 3, 1, 2, 4. Luckily, I mean, it matched the first three records, but it is not guaranteed that you'll always get the first. Okay, so the reason here in our case is it might have run only one reduce task. Let me see. Yes, the reducers ran is only one, because since this is a small input. Okay, so when you have multiple reducers running in your MapReduce job, then these values, you can't guarantee that you will get only the first three records from your input file. The same case happens even in Hive also. Okay, so if your data is really huge, and if you run the same query again and again, but if you put the limit, you may get each time different results because of your limit. Okay, and that happens even with your Impala. So the reason is when it is running multiple reducers, let's say if you have 500 MB file, so it has to run at least even if you take 128 MB size, it has to run 4 reducers. And you asked only for 100 records, let's say. So whichever reducer completes faster, from that it takes the 100 records. So sometimes R0 may get completed faster, and R1 may get completed faster, and R2 may get completed faster, and R2 may get completed faster. And here you may ask me why, even though I am limiting my result set to 100, why is it still running 4 reducers? Why can't it run only 1 reducer to extract the first 100 records? So the answer is, like, even Pig, Hive, Impala. So these are like as matured as your RDBMS tools. Okay. So especially with your limit, it executes, it processes the entire data, and from that result, it limits your number of records. Not like reading only the first 100 records from the input itself. Okay. It does all the querying. Even in Hive, if you apply some select conditions and all those things, and all group bys, all that stuff, and if you limit by this, so without this limit, this entire query gets executed. It's as good as run a query and limit. It takes the same amount of time as your usual query, even though you're applying the limit. Okay, but in Hive, there are ways to optimize that. But that is again not guaranteed that it will definitely give you the result. Okay, and performance improvement. Did you get answer to your question, Satish? So these are like the initial days of your Oracle. In Oracle, so nowadays it is optimized. Oracle engines are optimized such a way that if you limit, only it restricts the reading of records also, not just the producing the output. Okay, is it clear, Satish? Okay, yeah, thanks. Yeah, luckily we didn't see that records getting shuffled there, since it was just one reducer. So it can happen this way also. So cross product we have seen. So load and store, we have seen the examples there. Yeah, if you have a relation, a bag with 3 columns, and on any condition, if you want to split that into multiple relations, yes, you can do that. I have a relation A here, and split A into X if F1 less than 7. All records that matches with the first field less than 7 will come into X relation, and all that matches with F2 equal to 5 will come into F2. Okay, so F2 equal to 5, and Z if 3 less than or equal to 6, or F3 less than or equal to 6, or F3 greater than or equal to 6. Okay. Next, while testing, if you want to take any sample, so if you have 1 million records in this data relation, and if you don't want to run your subsequent pig commands on that entire 1 million, and if you want to limit that to just randomly take some records, like either you can, so here you can specify sample A 0.5 means it's 50%. So half of the records will get copied into X. Again, here randomly selecting those. This is a completely random selection.
One question here.
Mm-hmm.
In case we are trying to do this random sample records for a certain percentage, and if that doesn't serve the purpose, whatever output it generates, so can I do like next random records so that it doesn't pick the ones it has picked earlier?
You can try that. You can't guarantee that. It's randomness, randomly generating the records from the existing one. You can't guarantee that. It should pick only the next subset. I mean, I got your question that. So you selected 50%. It selected half of the records, and once again, if you run the sample A 50%. Into some other relation, you're asking about it will get the second half of it. It's not like that. It's not like that. It's a completely random selection.
Okay.
Okay. So it's like you have a basket of balls and you select randomly some 100 balls out of it. And again, if you go for another sample, put those 100 back and again take some 100 balls from that.
Okay, so it's like trial run.
Yeah. Okay. Next, union, same like in our SQL union. If you want to union your two select queries results, here you can union two aliases. Okay. So I will get the union of them. So 1, 2, 3, 4 to 1. After that, 2, 4, and 8. Here, the no need of the schema also to be matching. Okay. So inner joins, same like our SQL joins. I have a data set and B. This is with 3 columns and this is with 2 columns. And join A by A1 and B by B1. So whatever are matching, A1 4 to 1 and 4 6, 4 4 are matching. So 4 to 1 and 4 9 and 4 3 3, 4 6 and 4 9. So those are the matched records. This is the inner join. And if you want to specify the outer joins, syntax is pretty similar. Join A by what is the column that you want to join. And if you want to have left outer, specify left outer. Then all the records from your A will be included, whether they are having any matching records in B or not. Same like your SQL joins. And full join means it's complete. Either you can specify full or full outer. And similarly for right outer, this is the right outer join syntax. Okay. And these are some of the aggregation functions. If you want to take average of salaries or average of some ages or something, then you can do this. Let's say if I have these records, so I have 4 records with John and 4 records with Mary, and if I group by names, I have all these things. And if I generate a.name and average of a.salary for each B. So for each John, I will get what is the average salary. Either I could have specified generate group comma average of a.salary, then I will get the salary average here. Okay. And concatenate for concatenation of 2 strings, name comma. Here I have 2 fields, name comma MSC. If I concatenate them, generate concat of them, so they get concatenated. Okay. And tokenize is to split. Same like here. Okay. Here we have split means dividing one relation into one table into multiple tables. But here the tokenize purpose is, in Java we have seen that string dot split, right? The same. So tokenize of F1. So it tokenizes your strings by either space delimited or a tab delimited, all of them into, so this way. It gives you one inner bag with each with one tuple. So this is one string, one field tuple, this is another field tuple. So this is set of tuples, you'll get these. So tokenize. And same like the average, you can apply any of the aggregating functions like sum of all the salaries, or max or min. You can apply any of those, the aggregation functions here on a grouped results. So here one mandatory rule that you should have is to use your count function or average or sum or min or max. You can always apply these on grouped results. You should have your data set grouped by some column or grouped by all. Okay. So preceding these statements, these functions, you should have a group by statement. Otherwise, it doesn't make sense. Right. As you always have to pass a alias as a parameter to this relation column name or relation name. And these things will be always used with for each. For each, alias, generate, all these commands, aggregation functions will be used with your for each generate only. Same like in SQL, right? We use them with select and count of this and average of this, sum of this. We can only specify them only if we group by. In SQL also, if you want to select average of salary from EMP, then you should specify the group by which column. Okay, group by ID or group by department. So then for each department, it gives the average salary value. So it expects, if you are using any aggregate function in the select class, it expects you to have a group by in your SQL. The same way here in Pig. So before you apply this any aggregate functions, it expects you to have the group statements. Size is to get the size of a field. Like if you apply size on name, this returns 4 characters, this is 6, this is 5, something like that. Min, same like that, and max. And to check any record is having an empty value. Let's say if you have join B by sal and left out A by salary, here I have some empty records. And if I want to filter those records, filter C by is empty of name. If it is empty, so filter them out. I have only those empty records here. Okay. And if you want to get the differences between two bags, let's say I have a bag data. Inside this itself, I have two bags. This is as one bag and this as another bag, B1 and B2, or even separate bags is also fine. So for each A, generate diff of B1 comma B2. So from this 8 comma 9, 8 comma 9, the difference is 0 comma 1 and 1 comma 1. And then this 2 3 4 5, 2 3 4 5, same. 6 7 3 7, 2 2 3 7. So these two are different. Only those differences are shown in the result. Okay. So count we have seen already. Again, I got this. Yeah. So now we have seen the basic list of relational operators. We almost like coded around 60 to 70 lines of, or at least 55 to 60 lines of code in MapReduce to achieve that word count algorithm, right? So if I want to achieve the same stuff in Pig, let's see how much small it becomes like, how crispy it becomes like. Okay, so I will explain these anyway line by line. Let's do it on our own. Okay, let's assume I have this file, this text file. I have this text file. So it is having some this strings, right? So let me take this. First, I need to load this file. Okay. So input equal to load slash user slash Cloudera slash data. And what is my file name? It's Dropbox hyphen policy.txt. Okay. So in this, I don't have any delimiters there using big storage. Okay. So I don't have any delimiters. I don't need to specify them. I can leave it as it is, or I can specify as and line. Either I can specify as char array, or I can even leave that as it is. Input might be some keyword. Input is input file. Okay. So I got this. So whose syntax is, whose schema is input file. So this is nothing but it's having only one column. That column name is line, which is of string data type. Now I want to parse each of these lines. For parsing those lines, just now we have seen, I told you that we have a operator tokenize, right? Let me take tokenized equal to, for each input file. So for each record in input file, that means generate tokenize of line as, or we'll leave this till here. So let me dump here. Okay. What I will get? Let's see. Tokenized. Okay. So just give me a minute break. I will be back quickly. I think input is the cue. So yeah, sorry, I'm back now. So if you observe here, for every one input line, so your first line here is that, so this is your first line, Dropbox policy, and second line is last modified, so on so date. So if you observe there, so with Tokenize, each line is taken as one tuple, and inside that the Tokenize output is so an inner bag, and which is containing tuples of each words. So Dropbox is one field inside this tuple, and privacy is so this way. So that means your Tokenize resulted an inner bag. So before that, each line was a tuple. I could have shown you the dump of input file. So if I show the dump of input file, obviously you will have records of this way. So each line is one field, and your output will always be like a bag. Bag is nothing but a set of tuples. So you will get output that way. Okay. Now let me remove this. So that is the output of your input file. And after applying Tokenize, each line became split into multiple fields. Now I need to count each of these words. So first, to count each of these words, I need to group them by the similar keyword, right? So first, to group them across the multiple records, first I will make them as flattened, as each field into one tuple, that way. Okay. So now words equal to individual words for each tokenized. Okay. So generate flatten off or flatten off $0. Okay, so I have only one inner bag in each of them. Let's see, as each one has a word, dump words. See, now each word become a separate tuple. I just flattened it. I have separated them, each group into, so now it became a separate record, this became a separate record, this became a separate record, and this became, now this entire output is one outer bag, right? So this one I can group by word now. If I group by word, I will get all the drop boxes into one place, and all the privacies into one place, and all the policies into one place in this entire stuff. Let me do that. Okay. So grouped equal to group words by word. I have only one column that is named as word, and my relation name is word. So if I dump grouped See, you can observe all the informations are collected into one group. Same way, you can see if you go to top, all the dots and all the A's, all the B's, B space. Okay, all of them are grouped. Now, getting the count for them is very simple, right? Since you have already grouped them, word count equal to for each grouped, generate group comma count of word. Count of words, or make it $1 if you don't know. Oh, I'm using it in lowercase, that's it. Okay, so dump word count. It should give me the count there. So let's come back to the result. Let's see what are the commands that we ran so far. We didn't even need this. So we just loaded with one line. With one line, we loaded that. And with second line, we can even combine this tokenize of line and flatten also into one line as over. And after that, I applied the group by. And after that, I applied by count. That's it. I got the counts into this. And for printing them, I have one line extra. Or to store them, we have one line extra. If you want to sort them by any order, ascending or descending order, you can apply at max of another one more line of commands. So even if you take the sorted order of your own choice, like ascending or descending order, the total values, okay. So here you have at max of 6 lines of code. Whereas we have seen at least 60 lines of Java code in MapReduce. That too, that you have to write in Java and what is this? You have to write in .java. You have to compile it. You have to build a jar and then ship it onto terminal and run. Here, directly write commands. No need of, you come separately compiling and generating the class files, and no need of building a jar. Directly execute. Okay. Suppose if there is a one line code change in your MapReduce Java, again you have to go to source code and change that, make that change, build the jar, and copy that to your terminal, and then execute. So those many steps. The development life cycle is more. Here, just directly make the change and execute it. And here, almost like 60 lines of code, including mapper class and all the imports and so map method override and all those things. Okay, including mapper, reducer, and driver program. So this much of code, we were able to achieve the same stuff in 6 lines of pig commands. So that's how it abstracts the complexity of your MapReduce programming. So if I have the same requirement, which can be achievable in Pig, then I always prefer to go to Pig if I have these two options, MapReduce and Pig. Okay, let's now verify these counts. You can see these counts of okay. So if you sort them, you can get in the sorted order. Okay.
Shiva,
Yep.
we have to dump all these records. Can we have an option to only dump first 500 or first 100?
You can, right? I mean, we talked about limit, right?
Oh, limit. Okay. The limit will do that.
Limit will do that. Okay.
And same, it will be sorted also, right, with that.
If you want to order them,
Yeah.
sort them. You can do sorting by order by.
Order by. Okay.
Yep. I have seen the policy as 12 count there, and if you check for policy here, so max of how many counts this? 4, 5, 6. But again, this is a case sensitive also. Like in the notepad, this is case insensitive search, but here we didn't handle the case insensitivity. So if it is capital P, then only it will be considered into a count. So that way have total of 12 policies. Or match case. So here I have 4, 5 in the screen itself, and again 4, and then in between some 2 or 3. Five, 6, 7, and 4 here. Seven. Okay, I have around the same stuff. Okay, so that is our first Pig script, and instead of running this all these commands, so whatever the command, instead of running them one after the other, okay, let's say I have to write into a script, same like that. Yes, I can do that. So let me take each command by command. So this till now we have seen executing them by shell mode. Now let's see them writing into a file and executing as a batch mode. Or else I will take directly what's here, which is a so this is a tokenize of line and group boards by board and count and if you want to limit, you can also apply your limit or sorted output if you want, order vote count by, here you will get for each vote you will get the counts, right? So by $1 descending, I want to get the top most occurred fields in the descending order, and limited if I want to get only the top 10 keywords that are most frequently occurred. Limited equal to limit sorted output 10. Okay, so these are my pig commands. I have total 6 lines of code. Let me dump this. Okay. Dump limited, and I will save this as a .pig in my home folder. Okay, so if I come out of this pig shell, let that shell be running there. I might be using that later. If I want to run this, pig -f vote count.pig. It will run the same pig commands that are present in that file. Undefined alias tokenized. I used somewhere tokenized. It's not tokenized. Okay, so tokenized alias itself is not there, so it's correct error message only. Could not resolve count using imports. Again, I did the same mistake again and again. Okay, so the lower case of count is caused that problem. This time something else went wrong. Error, projected field vote does not exist in schema. Group array votes of tuple of. Generate flatten of tokenize of line and grouped votes by. This is how we use this. What is the problem here? Count of votes. Too many typos. Okay. Too many typos. So it got compiled and creating the jar. So there are no more syntax errors. Okay, so let that get completed. Let's see what else we have in the sequence. Okay, So some of the math functions. So these functions are self-explanatory. I don't need to explain them. For your reference, I kept all of these things in the slides. Okay. So to get an absolute value, we have ABS method, ABS function, some cos, sine, tan. These are, rather I would have removed all this stuff. We rarely use this stuff. Okay. Nowhere it's useful. I will. Okay. Yep. Maybe sometimes the floor and this log value is also not needed. To generate the random numbers, random of salary, it generates that. Okay. Round, square root, all these functions. Okay. Okay. So those are basic math functions. I removed those all cos, sine kind of functions. We never use them. Okay. Just instead of keeping them for the sake of. Okay. So next, so one important command that I want to show here is you can run all your Hadoop FS commands. We have seen Hadoop fs-ls, fs-cat, fs-copy, fs-put, all those commands, right? You can run all those commands from your pig grunt shell itself. You can run all your Hadoop FS commands within your pig grunt shell as well. It is still running. Let that run. So we have this grunt shell, right? So let's say instead of typing Hadoop fs-ls, all that stuff, you can directly type fs-ls /user/cloudera/data. Let's see what are the files that are present in this directory with ls-r.
Siva, sorry to bother you.
Yes.
The last line is not visible on the screen.
Okay, let me press Control L. I am just clearing the screen so that it will go to the top. Okay. See, now you can see this command, right?
Yeah, perfect.
fs-ls, or if you still have any issues, I can increase the font also. Okay. So the same command we used to run in the outside of pig grunt shell, we used to run with Hadoop. Hadoop fs-ls, this is the path, and we were getting this output. So what I'm trying to say here is that if you're already in a grunt shell, and if you want to run any Hadoop FS related commands, you don't need to close that grunt shell, or you don't need to reopen one more terminal and run there. You can directly run all your Hadoop FS commands within your grunt shell, and also you can run them from your pig scripts. Inside this pig script, if you want to check for a file like pig fs-ls or something, or if you want to remove your output directory, this is the typical requirement that you will get. Okay, so if you have that output directory already present, if you want to remove that, so pig_out directory, so it removes that directory before you store that into, let's say if you have a store command here, store limited into your pig out /user slash Cloudera slash data slash pigout. So if this is the directory into which you want to write, and if you feel like you always want to check whether the directory is present or not, if it is present, if you want to remove it, always put this statement so that it will remove. If this directory is present, it will remove. If not, that's okay. And using pig storage. This will avoid that file already exists exception. Right? So you can run your Hadoop FS commands with this in this way. And if you feel like some of your input files are present in your local file system, you can run that before even getting them into load statements. You can run fs-put statement, give your local path, same command, a local directory /home /Cloudera and / your file name .txt into your target directory on Hadoop. Get that into there and then use that HDFS path in your pig and process that and remove this. This way, I'm able to run my FS commands, Hadoop FS commands from the script itself. Okay, so this is your assignment link in pig. So take an input file in your local file system, upload that into pig assignment. Create a file in LFS and upload that into and even creation of that file and writing the contents into LFS file should be through pig script only. Okay, write a pig script which does below actions. Okay. Yeah. Create a file in LFS and write some sample text into that. So how will you write some sample text into your Linux file? Either you can use echo or you use redirection parameters and then upload that into HDFS, load that file into pig and show the word counts. No, store the word counts. Word counts into HDFS and copy that output file into LFS. So this much it has to do that. And second, practice all the relational operators. And third, string functions. Explore all the string functions. What all string functions you can do. So we have seen tokenize, concat. Similarly, we have substring. we have index to, and we have upper to convert that into uppercase, and lower, and we have split, we have reverse. So there are so many string functions. Okay, so explore all these string functions and provide me one example of usage. Okay, provide one example usage for each of them. And next, let me take remaining stuff. Yeah, let me write down the commands. Okay. So, something we were running there, right? Yeah. So the same script I ran in batch mode and I printed those counts. So now can you see the top occurred keyword, that is 2. Next, which is with 88 count, and your is 80 times, and you is 60 times, 65 times, D 63. These are the top 10 results. Okay. And the way you can run your Hadoop FS commands from your pig grunt shell, you can also run your Linux shell commands also. Let's say sh pwd, it prints your current working, present working directory, print working directory. The same output you will get here, pwd, here also. Like sh echo hello. So echo hello is a shell command, right? So it prints hello. The same I can run in the grunt shell just with sh command. Prefix. So you need to use sh extra here, and with your Hadoop FS commands, no need of Hadoop. Directly use FS. It will identify it as a Hadoop file system command. If you use sh, it identifies this as a Linux shell command. Okay, so almost all your shell commands can be run with this. So that will be helpful in creation of this. Create a file in LFS like hello and redirect this into file.txt. Now if you see that, it could have created in your home directory file.txt. Hello is created. Okay. So I have shown you how to do that also. And store your HDFS file back into your local file system. Next, let me move on. So this FS is to execute your Hadoop commands, and SH is used to execute your Linux commands. Okay, and clear we have seen. And if you're already inside your pig grunt shell, and if you have a script that some statements written into .pig script, you can use exec space followed by your script name. If you are outside of your grunt shell, the command is pig space -f space the file name. Right? Here, if you're already in the grunt shell, if you want to run that script, exec and script name, or run and script name. Either of those are fine. And if you want to see the history of your commands, you can do that. If you want to verify what are all the commands you have executed so far. And then this, you can also do a reverse search of like how many times you use describe or. So if you want to search, same as your control R in your terminal. So in the terminal, if I look for control R, the pig, see if I type pig, so whatever the commands that that are having this pig keyword in the history, that those will be listed. This is control R, and the same control R, the reverse search in the history is available in pig, and history command is also available in pig, same as your terminal. In terminal, you have the history command. Here you have this. So these are the commands that we ran so far from yesterday. Okay, and show me, give me your history of that tells me what all commands that you practiced. Okay, so store the result of your history command into a file and send me that file. So by looking at this file, I can understand, like, so what are the commands that you practiced? That itself is suffice to review how much practice you are doing. And then grunt shell. Okay. So count caps, or you ping something. Yep. And if while running inside your grunt shell, you have seen the jobs being submitted there, you will get the job IDs here, right? And while running that, it produces the job ID there. You can see this job ID, submitting this job ID. If you want to kill that, and within the grunt shell, you can use kill and followed by job ID to kill that job. Or if you want to come out of your pig shell, quit command, and you can set some configuration parameters also in your pig shell, and this set command is applicable in all these three, like pig, hive, and impala. The same set command used for the same purpose of setting your properties. Set debug on or set default parallel equal to 100. This means this property is for setting your 100 reducers parallelly by default. And this will set MapReduce.child.java options. It for either map and reduce tasks that get submitted in the background uses maximum of 2 GB memory for each of those tasks. Okay. Run is also same as exec, as I told you there. So if you have a script file and if you're already within a grunt shell, you can use the run command followed by the script. Okay. So local mode, I don't highlight that. MapReduce mode we have already seen. Pig debugging commands. And so how many are? Still we have 12 more minutes. Let me see how much we have. Yep. So I have enough time to finish this. Okay. No hurry. Now, so while you are running any of your commands, so we used a couple of debugging commands so far. We have seen describe to check whether that file, whether the previous command generated the proper schema or not. Just to view the schema, describe, and dump to view the results of your execution. sometimes this dump will result in displaying all the records, right? And if you don't want to see the complete executions of them, we have another alternative, illustrate. So this will take only sample of records and it will explain you the sequence. Okay, so here this explain and illustrate, we have two commands. Explain will show just the logical and physical plans. How many map phases are there? So for example, in our word count scenario here, so let's, what is this? This is the word count, right? And we use the dump of word count. Let me explain the word count now. So explain, the purpose of explain is same across Pig, Hive and Impala again. So almost all these commands, the describe is also present in Pig, Hive, Impala. Set command is also present in Pig, Hive, Impala. And I think exec is not there. Yeah, there are some commands like, so you'll see the same command is present in all the three tools and the purpose might be almost same. Okay, purpose is similar purpose. So if I specify explain word count, so it prints me both the logical and physical plans. So physical plan talks about where exactly your file is located in and how does that happens and all that. So this is your MapReduce plan. Let me show you the physical and logical plan. Okay. So this is the logical plan, and we have the physical plan also. Okay, so it helps you like, so if you see this physical plan, you need to look at it from bottom to top. Okay, so first step is like input file, loading this so and so file. It exactly shows the path as well. Okay, so once it loads that, it receives a byte array. From there, it casts that into char array, and after that you are applying the this from this so and so package, you are applying some user function tokenize on this bag, and so for each of these bags you'll get some words from there, rearranged couple of char arrays. Like this is applying rearrange means that it's a flatten. Okay, and after that you are grouping them. So after grouping, by this you can assume that this is group operations are happening, and then you can see the count getting applied from this so and so package, this class being called, and you'll get this word count. So this is a physical plan. It displays exactly the physical locations and the paths of your classes, that from where it is getting invoked actually. In the logical plan, you won't be seeing all those physical information. Like it loads the input file, that's it. So what is that location of physical location of that file, you will not be able to see here. And once you load that, first you will get inner load. Inside that you will get a byte array. So this logical plan, you can mostly observe the your casting conversions, like initially the byte array. So byte array got converted into casted char array, the string, and then it applied this user function on that. It's more or less same. Okay. So words, after that, every word got grouped. So it generated a bag, which is of, so first field, with a tuple board, comma, char array. And from group, you will get a group element which is of char array, boards which is of bag, again this way. Schema at each level. Okay. And this is grouped and this is word count. And so these days from last few releases, we can also see the MapReduce plan in this. So MapReduce plans are like map plan. So map plan. So what all steps will be executed as part of this plan? So input file and combine, and this is a map plan. This is a combine plan, combiner. So here you have reduce plan. Like what will be run as part of your reducer phase and what will be run as part of your combiner phase. What will be run part of your, see, intermediate counts are being calculated in the combine phase and the final counts being calculated in the reduce phase. Same like as that we did in MapReduce. Okay, so you can see logical, physical, and MapReduce plans with explain command. Now, let's see the fourth variety of the debugging command, illustrate. So it is more user readable or understandable than the explain. So it actually executes. Explain will not execute. Okay. Illustrate will execute by taking some sample records and shows you this outputs. It's a kind of basic testing. See, it shows all those values, outputs also in the every intermediate phase. So if you go to top, and this is a flatten of this. Okay. See, our first statement is input file, which is loading your file, and the output of that is, so it took some sample lines. Randomly, it took some sample line. It took one line here. So after applying tokenized, obviously this will become our as one field and comma dot dot last file. See, this is how this is explaining, showing those intermediate results. Now after tokenized, you got this. After applying flatten, you will get this. Flatten R become one separate field and services become another services, R another, not directed till files, you will see. Okay, so you can see till files. And after that you applied group by. So group by, for A I have 2 A's, and for 13 I have 13, 113. For if I have 2 ifs, that way I have this many. So this is my grouped result from that. And this is the final word count result for that input sample line that it picked. A occurred twice and all this thing. So this is sometimes useful while debugging, whether your logic is working properly or not. Okay. So these are the 4 debugging commands. So people might ask you, if you say that if you are from big background, they might, during interviews, they might ask you around this slide. The SQL versus pig comparison, I think we have already seen, but let's see some of them for now once again. So select star from table name users. It's like for each generate, for each users generate all or generate star. And here if you have this select star from users where weight less than 150. It is like filter users by weight less than 150. And select only name comma age from users where weight less than 150. Then on this skinny users where we applied the 150, I am selecting for each skinny users, generate name comma age, only those two columns. And here, if I apply some aggregate function sum of order amount from orders group by some name, here we apply that group orders by name, and for each A generate $0 as name and sum of $1 dot order amount. Having some greater than, which is again like another filter condition. This is not the one. Okay. So order by name ascending, this is the same. Order C by name. And select a distinct name from users. Here also, like first you select the names, select use for each users, generate name. And to get the unique names equal to distinct of names. Two statements, just for one line. Okay. Select name comma count of distinct of age from users group by name. Then I should select first the group users by name. First, since I need to group by name, then num ages by name, ages and name for each user by name. So select, you can run curly brace, you can put your queries inside this also for every record. So ages equal to distinct of user.ages, generate flatten of. This is bit kind of nested coding for each username, and inside a curly brace you can put the statement. Okay. The next, interacting with HBase, we have HBase storage handler. This path. Anyway, this use this as a reference for now, and refer to this syntax to read in your HBase table once after we complete the HBase topics. Okay. So HBase and followed by your table name using this. Earlier, we were using load path using pig storage. But if you have to read your HBase table, same command load only, load your HBase :/ followed by table name. Using, instead of pig storage, we have HBase storage. And from that HBase storage, what are the column families and column names that you should read, and how you want to name them inside your pig ID, dim, and OMG, MD are my column names, and their data types are char arrays. Okay, so this is here, it is just for your reference. Come back to this once after your HBase sessions completed. Then you will be able to understand that. And we have seen pig storage, and we have seen a bit about HBase storage. We have bin storage as well. So it will store your data in the binary format. Store B into so and so path using bin storage. It writes that into binary format. Okay. And again, you can read that binary formatted data using the load command, load using the binary storage, and specify the field. So it converts that into bin. But this is not much widely used. You can, for your practicing, you can try it out. So similarly, we have text loader. Without it reads that entire file as it is. So one line as one field without schema. Okay, and this is again not widely used. So if you have any JSON file, you can specify with JSON load. So load, specify the JSON file path using the JSON loader, and specify what are the fields that you want to extract from that JSON file and what are the data types to be. You see here, have food, person, and amount. I have 3 key value pairs in my JSON. But if I use the JSON loader and specify only food : char array, I will be extracting only the food key value pairs. Those values here. And ORC storage. ORC is one such file format. I was talking like sequence files, Avro files, and RC, ORC, and Parquet. Okay, so this is just one example how to store your data in the ORC format, the ORC file format. So load any of your text file using the pig storage. While storing that, so store A into using ORC storage. Just that's enough. Whereas if you had to write into ORC file format using MapReduce, it was so complex. Okay, that's why I skipped that, showing that format. And similarly, you can find your RC storage. You can try with your Parquet storage also. Okay, but again, I'm limiting the scope here only for ORC file formats. Why? You will understand during our Hive sessions. Why I'm not concentrating on that portion here in MapReduce or Pig much. Okay, so these are some of the string functions to get the index. So whether your given string is present in another string or not. If it is present, at what index it is present. Last index of what is the index of last occurrence. Lowercase the first character, and lower converts all the characters, and regex extract, same like your SQL. Inside your SQL, you can specify regex extract and your input string and your pattern, and it returns those matching those stuff. So do we have any skew joins in Pig? Yes, Satish, we will discuss them on Monday. Okay, so I have those listed in our slides. We'll discuss them as part of optimization techniques. Okay, so we'll discuss them. And replace, let's say for regex extract, so username *test. Whatever matches with test, I will get all of them. Cast test and latest, all will come. It is starting from 0 index. And replace fastest with latest. So the fastest become latest. The best, the best. String split, it's again same like your Tokenize. Okay. I have this flatten of string split of A1. So this A1 by dot, if I split by dot. So this is a unique code that we specified here. Or you can try with directly dot also. Substring trim for eliminating the leading and trailing white spaces, same as your Java or SQL. You see uppercase first letter and upper for converting all the letters into uppercase. So yeah, these are some of the functions, string functions. I want you to practice all these things. And these are self-explanatory, okay, not complex. I don't need to spend much time explain all this stuff. So till here, I want you to be thorough with your practicing. Okay, so we'll discuss the user-defined functions. So far we have seen the built-in functions. What if you need anything custom function? So those we'll discuss them on Monday, the user-defined functions. also we'll see the optimization techniques for making your pig scripts run faster. So here you have that skewed joins, Satish. Okay. And yep, on Monday, in the first 1 hour or so, we'll finish off the pig concepts. Then we'll enter into the Hive. At least I will give you the introduction to Hive.
Siva,
Yes, Anand.
how much time do you spend on Pig versus MapReduce?
For sessions,
No, for in your real life.
real life, MapReduce 5%. Pig, at this point of time, I should not tell this. Pig 0% from last 1.5 year.
Okay.
Last 1.5 year or 2 years, it's almost zero
Wow.
in my real time. Okay.
Well, I like the honest.
I can tell you where all my time is going on. Like, so Hive, I can say 20%, and Impala almost like 50%. So already gone like 75%, right? And another 20% into HBase and 5% into Scoop, OZ. Scoop and OZ. Yeah, this is based on last 1 year or 1.5 year. Okay. I mean, excluding Spark and Scala in this, if I consider only these Hadoop tools. If I have to consider Spark and Scala, then I should reduce the Impala percentage to 30 or so, and Spark around 10 to 15%.
So the Impala is really important then. Looks like that's the major chunk.
Yeah. If you are with Cloudera's distributions. If you are with Hortonworks, then obviously people will go for Spark to get the same in performance. Of course, you can still go with Spark even in Cloudera. But so in my case, it's the curve of my efforts, my time's being spent. Okay.
Perfect. Thank you.
Yeah. Thanks, guys. So that's why, I mean, I gave you the knowledge how much is needed for your real time. Okay. So, hey, I need some help on Spark. Yes, Akila, can we discuss this tomorrow, or you want it right away? Because we just started with Spark.
Yeah, actually, the installation part, I'm facing error.
Installation part.
Yeah,
Okay.
like 1.6, I have installed. I have set the bash RC file and config in the conf like in the lib. Sorry, it's SBIN. I went to all the services and started the services, but I'm getting some SQL console error, something like that when I start the.
I mean, don't even do that. Okay. First, you extracted your Spark, right? And said that
Yeah.
.bash archive file, right? So just start your Spark shell. That's it. Enough.
Yeah, I did that only. I got the error, so I went and started even the services, and even I'm facing the same error.
Oh, okay.
Even I've given a try by giving a class path also, but same error.
Okay. Let me look that. Okay. Yeah, I will see.
Okay.
Yeah.
Okay. Thank you, Shiva.
Yeah, I will stop. I will end this meeting. Maybe you can connect back in another couple of to the same link.
Okay.
So that you can share your screen, and I will try to see what is the root cause. Okay.
Sure.
Okay.
Thank you, Shiva.
Yeah, thanks. Bye-bye.